Let us continue our discussion on everyday problem-solving skills. Last time we discussed these four problem-solving skills, so today we will be discussing these last four problem-solving skills. So in the first skill that we will learn today is suggesting hypothesis. Consider the following example. Mark has recently had a set of books printed. When he ordered the books, he was told that the cost for each book would be calculated as follows. So let us highlight the important terms. 100 pesos for the cover and binding, 1 peso for each page in black and white, and 2 pesos for each page in color. Any order of more than 50 books receives a 1,000 peso discount. Okay, so if you order more than 50, then you get a 1,000 peso discount. Mark originally ordered 40 identical books with 50 pages each. Okay, let us stop for a moment and let us determine the price of each book. Is it possible to determine the price of each book given this piece of information? So please pause the video and think about it. Okay, and the answer is no, because although we know the number of pages and we know the number of books, we are not sure whether the pages are in black and white or in color. So we cannot determine the price of these books. Okay, but later, he needed to change his order. When he changed the order, the total cost increased by 400 pesos. So this is the only thing that we know. We don't know the exact price of the books, but when he changed the order, the total cost increased by 400 pesos. Question: which of the following could be the change that Mark made to his order? So in the modern world, we want to find a way to explain things. So that is the skill being taught by suggesting hypothesis. We are looking for an explanation for why this increase happened. Okay, let's consider option A. The number of books ordered was increased to 45. If that is the case, then what will happen to the change in price? Well, again, the number of pages will increase because we ordered 5 more books. Originally, we ordered 40 books. We changed our order to 45. So the number of books ordered increased by 5. So that means we will at least increase the total cost by 500 pesos because each book, the cover and binding for each book costs 100 pesos. So our price will, again, 40 to 45. We increase the number of books by 5. So at the very least, we will increase the price by 500. And there will be an increase other than 500. There will be some amount more because of the pages of the book. But we do not know whether they are black or white and colored. But it is already enough to eliminate option A because the increase is only 400. Okay, by the same reasoning, option B can be eliminated because if we increase the number of books from 45 to 60, from 40 to 60, the original number is 40, that means the number of books will increase by 20. But each book, because of the cover and binding, will increase the price by 100. So that means our total cost will increase by 2,000 plus some more because of the number of pages. But we have to take into account statement 4, namely that if we order more than 50 books, which is the case here because we ordered 60, we will receive a 1,000 peso discount. So that means this 2,000 will be lessened by 1,000. But even if that is true, the amount will still be, the increase in amount will still be at least 1,000 plus some more because of the pages. So again, we can eliminate option B because the addition in the price will be too much. It will be more than 400. For option C, if the 5 page if each book 5 pages from each book were changed from black and white, well, let us see what the change will be if this is true. If 5 page if a black and white was changed to a colored page, so that means the increase in price will go from 1 to 2. So that means the increase is only plus 1. Okay, so I hope you understand that again, if you go from black and white, the original cost is 1, and you change it into a colored page that will cost 2 pesos, that means the increase is only 1 peso. So if 5 pages were changed from black and white to colored, the increase will be 5 times the amount of increase per page. That means positive 1, a change of 1. So that means our cost for each book will increase by 5 pesos. But there are 40 books in total. So that means the total increase will be 200 pesos, which is not 400. So we can eliminate option C. So by elimination, the answer will be D. But as an exercise, let us check that it is indeed the correct answer. If 10 pages from each book were changed from black and white to colored, again, the increase for each change is 1 peso. From 1 to 2, the increase is 1 peso. And you change 10 pages. So that means for each book, the cost will increase by 10 pesos. Again, we have 40 books in total. So the total change will be 400, which is what we want. So that means letter D will explain the change. That is the hypothesis that we are looking for. That is the explanation. Letter D will explain the increase in price. In the modern world, we are bombarded with a lot of information. In data sufficiency, the task is to look for the minimum information needed to know something, the minimum information needed. We do not need to know all the information. Okay, so consider this example. An oil tank can be filled using one or more of 5 sources. So that means we have 5 sources. Source 1 fills the tank at 10 liters per second. So the rate at which the tank is filled is 10 liters per second. Source 2, 20 liters per second, and so on. Source 3 at 30 liters per second, source 4 at 40 liters per second, and source 5 at 50 liters per second. Currently, the tank is being filled at 90 liters per second. So using one or more of the 5 sources, the total speed is 90. Okay. The question, which of the following would be sufficient to identify with certainty which sources were being used? So again, we are looking for the information that is enough to explain why we are filling the tank at 90 liters per second. So what does that mean? So first, let us make sure we understand the problem. Of the 5 sources, we should be using at least one or more. What will give us a total of 90 liters per second? So pause the video and think about it. Okay, so one possibility is, first let's assume that we are using the source 5, 50 liters per second. If that's the case, then the total is 90. We are already using 50, 90, that we are using 50, so that means we need 40 more. To produce 40 liters per second, we should be using source 4. So this will give us 90. But there is a second possibility. What can fill this 40 liters per second to produce 90? Okay, another possibility is 30 and 10. 30 plus 10 gives us 40, plus 50 gives us 90. Are, are there any other possibility that can produce 90, assuming we are using source 50, source 5, well, there are no other possibilities because the only way to produce 40 are these two possibilities. So if you try as you might, you cannot form 40 using these four sources other than these two. So that's all the possibility. Assuming we are using the source 5, these are all the possibilities. So next we consider the possibility where we are not using source 5. So we are making our search more organized, okay? So that means let us assume that we are using source 4. What are the ways to produce 90? Well, one way is to use sources 3 and 2. That will give us a rate of 90 liters per second. Are there any other possibilities where we use source 4? Well, there are no other possibilities because we to assuming we are using source 4 and we want to produce 90 liters per second, the remaining sources should produce 50 liters per second. But the only way to do that using sources 1, 2, and 3 is to use these two. So these are all the possibilities, assuming we are using source 4. Okay, so can we get any other possibilities? Well, if we are not using source 5 and source 4, then the only possible sources are sources 1, 2, and 3. But the maximum rate, if we use all of them, is 60. 10 plus 20 plus 30 is 60. Not enough to produce 90. So that means these are all the three possibilities to produce a rate of 90 liters per second. Okay, so again, that can sound a bit intimidating, but we are simply making our list more organized. We are looking for all the possibilities that will produce a sum of 90. And this is the complete list. We are sure because our search was very organized. Okay, so question. Which which piece of information will be enough to identify which sources were being used? Okay, let's look at option A. If one of the sources being used is source 2, is it enough to know which of the three? So that means we have three possibilities. We do not know yet which is the actual scenario. If we know that source 2 is being used, can we determine which of the three cases is in fact true? And the answer is yes. If we know that source 2 is being used, then we know that this is the scenario that's happening. Because this is of the three possibilities, this is the only one that uses source 2. So that's the answer. Okay. Again, just to check our answer, if just to convince ourselves and as an exercise, let us show that options B, C, and D are all incorrect. If source 3 is being used, can we know for a fact which of the three is the scenario? The answer is no, because if source 3 is being used, we still have two possibilities, namely this case, 50, 30, 10, or this case, because source 3 is being used, 40, 30, 20. So we still have two possible scenarios left. So we cannot know for a fact which of the two is true. So source B is incorrect. Option B is incorrect. The same is true for option C. If source 4 is being used, then that means 40 is being used. But there are two possibilities, 1 and 2, 1 and 3. So we do not know which is true. And source 5, if source 5 is being used, then we still have two possible scenarios, namely these two, 50-40 and 50-30-10. So option D is not enough to know which is the case. So only option A is correct. In the modern world, we should be able to use models, or in this case, graphs, to describe scenarios. Here, we have to use your imagination to answer the question. The diagram shows the shape of a container that is made from two cylindrical sections. So we have here this shape. This is a cylinder. So imagine this is like a pipe, a cylinder that is relatively bigger at the bottom and relatively thinner at the top. There is a hole at the bottom of the cylinder. So here we have a hole. Water is poured into the container at a constant rate. So we have water filling the container. Once the level of the water has reached the hole, so initially we are filling the container without problem, but once it reaches this point, water will still fill the container, but at a slower rate because the hole, water will flow out of the hole. The water starts to leak out at a constant rate that is half the rate at which water is being poured. Since the rate at which water leaks out is lower, water leaks out at half the rate at which it is being poured. So, for example, assuming that the container is being filled at 10 liters per second, water is leaking out at a rate of 5 liters per second. So that means the water level will still rise because the rate at which we are filling the tank, in this case 10 liters per second, is still faster than the amount that is leaking out. Question: which graph best represents the rise in the level of water in the container? Okay. In this example, we need to recall a concept from algebra, and that is the concept of slope. I hope you remember the slope. The steeper the slope, the faster at which something is happening. So for example, if the rate at which we are filling the tank is relatively okay, so the our graph might look something like this. So that means as time passes by, the water level rises. This is the height, the water level, and this is time. If we are filling the tank at a very fast rate, our slope will be steeper, something like this. So compare these two. Imagine this is a mountain. You can climb this with difficulty, but if you try to climb this mountain, it is more difficult to climb this because it is steeper. So that means we are filling the tank faster. At a small amount of time, water level rises very quickly as compared to this scenario. So if this is your slope, it is not steep at all. If you're trying to climb this mountain, you can walk leisurely because the water at which the level rises is not that quickly. At for us for a small amount of time, the water level changes very slowly. So again, if the slope is very high, it looks like if the slope is okay, it will look like this. It is not that steep. Water level does not rise that quickly. If the slope is very steep, then water level rises very quickly. If the slope is not steep, then the water level is not rising fast enough. Okay. So with this knowledge, let us answer the question. Initially, as you fill the tank, because this part of the tank is bigger, this part, let's call this the lower part, and let's call this the upper part. The lower part is fatter than the upper part. So that means if you fill the tank, it will do so relatively slowly because this part is big. So we expect the first part of our graph should have a relatively low slope. But as you fill the tank, once it reaches this level, water will leak out. So that means our slope will even be lower. So maybe the first part instead of saying it l- as as a low slope, maybe we can call it a medium slope. For the first part, we get a medium slope. For the second part, we get a lower slope. Again, water is filling this tank. Initially, it's going okay, but once it reaches this hole, the rate will be lower because of the hole, so we expect a lower slope on the second part of the graph. On the last, once it reaches this level, so we have three scenarios. Scenario one, the first part is this part. So that's the first part. Water is not yet leaking out. The second part is this part, where water is starting to leak out. Once we reach this level, we expect that the slope will be steeper. Why? So here, maybe it will go up. So medium, low, and this will go higher. Higher compared to the second one. So why is that true? Because once you reach this level, the part of the container will be thinner compared to the initial part. So we expect the rise in water level to be faster. Although water is still leaking out, this part of the tank is thinner or less fat compared to this part, the first and the second parts. So although water is leaking out, we expect the slope to be steeper for the last part. Okay, so with that said, which of the four graphs can explain will satisfy these three requirements? Okay, let's check. Here, the slope is very low. For the second part, it became higher. It became steeper. Again, steepness can be imagined as the difficulty in climbing a mountain. If you, for this part, it has an okay slope. This is very difficult to climb, so that means the slope is steeper. So this is a higher slope. So this is the medium slope. And this is a very low slope. Because if this is a mountain, you will not find it difficult to climb. Here, the slope became steeper, which is not the case because we want a lower slope. So we expect a lower slope. From the first to the second, we expect a lower slope, so we can eliminate A. For letter B, the slope is okay. It's relatively steep. For the second part, it became lower, which satisfies our requirement. But for the third part, it became even lower. Again, if this is a mountain, difficult, easier, and this is much easier to climb because the slope is very low. So for the last part, the slope became even lower, which does not satisfy what we want. So letter B can be eliminated. For letter C, okay, our slope is okay. It became steeper, which is not the case because we want a lower slope. So letter C can also be eliminated. So by elimination, the answer is letter D. But let us check if we satisfy the requirement. The slope is okay. For the second part, the slope became less steep. It it's Here it's difficult to climb. Here the slope is lower, which is what we want. And for the last part, it became steep again. It became higher again, which is what we want. So indeed, the correct answer is letter D. Again, if you find this confusing, please comment down below so I can explain further. And the last skill that we will learn today is spatial reasoning, which is mostly about visualization. Vinod and Sarah are about to move some cube-shaped boxes that have been left in the middle of a storeroom. The appearance of the boxes from above and the positions of Vinod and Sarah are shown below. So from the top view is this. This is the top view. Vinod is here and Sarah is here. Vinod sees this. Question. Which of the following cannot be the view that Sarah sees? Okay, so if you want to answer this question on your own, pause the video and think about it. Okay, again, this is the top view. For simplicity, let us call this the left of Vinod, the middle of Vinod, and the right of Vinod. And from Sarah's perspective, this will be the left of Sarah. So here is the left of Sarah, middle of Sarah, and the right of Sarah. Okay. Vinod sees this. So that means from Vinod's perspective, on the left, there are two blocks. So that means the maximum number of blocks on the left of V node should be 2. For example, it can be 2, 1, for example, or maybe 2, 2, or maybe something like this, or maybe both are 2. But we are sure that at least 2 should appear once on the left of V node for him to see 2 boxes, 2 layers, and the maximum should be 2. 2 should appear and it is the maximum on the left of V node. On the middle of V, in front of V node, the middle part, he sees 4 layers. So that means, again, this is the top view. So that means at least one of these 3 blocks should have 4 stacks, should have 4 layers. And 4 should be the maximum. So that's the requirement for the middle of V node. At least one of these 3, 1, 2, 3, at least one of those should have 4 stacks so that he will see these 4 layers. And the maximum is 4. So one possibility, for example, is this. If that's the case, then VNode will see the 4 stacks because that's the highest layer. He will see 4 layers, something like this. 4 layers. Okay. Another possibility is all the layers is 4. That's also a possibility. The maximum is 4 and 4 should appear. Another possibility is 4 is here and you have 1 here. So he will see the highest stack. And lastly, on the right of VNode, he sees 3 stacks. But we only have 1 stack on the right of VNode. So automatically, this will be a 3. So we are sure that this is a 3. So this is sure. We cannot delete this anymore. Okay. So which of the following cannot be a view that Sarah sees? With this piece, with this last piece of information, we can immediately answer the question. So which is not possible? And the answer is D. D is the answer because the middle stack, these are the view from Sarah. The middle stack, Sarah will see at least 3 because this is already 3. Whether whatever the numbers here are, even if it's as low as 1 or as high as 4, we are sure that Sarah will see at least 3 layers in the middle. At least 3. 3 or more. But in this option, Sarah only sees 2 layers in the middle. So the answer is D. Okay. Again, as an exercise, although this is already the correct answer, let us show that letter A is not the correct answer. And you are left to show that B, C, and E are also possible is left as an exercise. Okay, is option A possible? Can it be a view? And the answer is yes. Again, if this is 3, if Sarah sees 4 layers in the middle, so that means in the middle here, Sarah's middle, there will be a stack of 4 boxes. So this is a possibility. We have 4 here and there's some number here. Sarah sees 2 on the left. So this is from the perspective of Sarah. Left, middle, right. Sarah sees 2 layers on the left. So a possible number here is 2. And maybe some other number here, maybe 2 or something else. Let's say 2. So, oh, by the way, this is not possible because from Vinod's perspective, the column on the left should have at most 2. But we placed here 4, so this is not a possibility. Okay, so this is a possibility. V node, on the left of V node, we have maximum of 2. In the middle of V node, we have 4. From Sarah's perspective, on the left of Sarah, we have 2, which is what we want. In the middle, we have 4. And on the right of Sarah, we have 2. So if we place 2 here, we satisfied all the requirements. All the requirements are the following. V node left should maximum of 2, so that's okay. V node middle, maximum is 4, that's okay. And on the right, you have 3. From Sarah's perspective, on the left of Sarah, we have 2. Middle of Sarah, we have 4. Maximum was 4, which is the case here. And on the right, we have 2. So if these are the number of stacks, then we satisfy both Vinod's perspective and Sarah's perspective. So option A is possible, so it's not the answer. Okay, maybe let's do letter B, just to make sure we understand. Okay, again, we don't delete 3 because that's already fixed. Okay, is this a possible view from Sarah? If Sarah sees 4 layers on the right, on the left, so this is the left, middle, and right. If Sarah sees 4 layers on the left, so this is the left of Sarah, at least one of them should have 4 stacks. Can we place 4 here? And the answer is no, because from Vinod's perspective, on the left of Vinod, the maximum should be 2. So we cannot place 4 here, so by elimination, 4 should be here. On the middle stack, we see 3. So that is the case here, 3. That means we cannot have a 4 here because otherwise Sarah will see 4 layers, which is not the case. So that means the maximum on the middle should be 3. So maybe we can place some number here later. And on the right of Sarah, we only see 1. So by elimination, the right of Sarah is this box. So she only sees 1 box. So now let us place some numbers here satisfying both Vinod's requirement. So for this layer, the maximum is 2. So maybe we can place 2 here. And for this layer, the maximum is 4. But again, from Sarah's perspective, the middle should have 3 layers. So we can have, although the maximum for V node here, for this column is 4, we cannot place 4 here because otherwise Sarah will see 4 layers in the middle. So maybe it's a smaller number, maybe 3. Okay, let's check if we satisfy all the requirement. On the left of V node, the maximum is 2, so that's okay. Middle of V node, the maximum is 4, that's okay. And on the right, we have 3. Okay. From Sarah's perspective, on the left, we have 4. That's correct because the maximum is 4. On the middle, we have 3. Maximum is 3. That's correct from Sarah's perspective. And from Sarah's perspective on the right, the maximum should be 1. That's correct. So this is a possible scenario. If this happens, then V node and Sarah's requirements are attained. So that means option B is possible, so it is not the answer. So convince yourself that options C and E are also not possible. So thank you.